C. It'll add A, B, and C and it'll give you the carry. Now let us look at the table first because that's easier to understand rather than looking at the Boolean function first. So A and B and C n, these are all that is the nth A, the nth B, and the nth C whenever it is coming when n is the term. Now, so this is the sum, and this Cn plus 1 is actually the carry. So for every n, the n Cn plus 1, for every A, n, B, n, and Cn, the Cn plus 1 is the actual carry. Now, obviously, as we know, look at the adder. 0 plus 0 plus 0 is 0. Obviously, there's no carry. Then you have 0 plus 0 plus 1 is 1 and there is no carry. Like this it goes on. As you can see the table, if I just hold it to you for a bit, as you can see, yes, 1 plus 0 is 1, no carry. Since similarly 1 and 1, it gives you a 0 and a carry of 1, as you already know. 1 0 0, they give you a 1 and no carry. Then if you have two ones again, there will be a 1, there will be a carry and a sum is 0. Wherever there are two ones, there is a 0 1 because obviously 1 plus 1 is 1 0. So 1 plus 1 is 1 0, so 0 and carry 1. When you have three ones, on the other hand, you have 1 1, which is 1 and 1 carry. 1 plus 1 is 1 0 plus 1 is 1. So you have 1 and 1, and when you're talking about the bit, it gives you a carry. So given these three bits, the adder will give you a sum of those three bits and a carry that emanates from that addition. What kind of addition? The answer is obviously binary addition. As we know that the circuits inside a computer, the transistor circuits inside a computer, they are bistable uh, devices. So they've got the zero state and a one state corresponding to some voltage levels. So that's what it is. You're representing everything in zeros and ones. So if the first bit is a zero, second bit is a zero, third bit is also a zero. Okay. Shomila Maiti has joined in. Hello, Shomillo. Good morning. Now, as you can imagine that if 0 is represented and 0 is represented and 0 is represented, then yeah, three zeros are there, three zeros are represented. The sum of those three zeros is going to be 0, so the sum bit will be 0, and like this. So now let's look at, now you see, when you are doing this, you see, how are you going to do this? You are going to put these three through adders. Now what is the construction of the adder going to be like? So let us look at the equation of the adder. From this side you can see that the result is been given by A and various combinations of A and B and C. As you can imagine, or as you already know perhaps, that this zero, sorry, beg your pardon, this point here, this is actually the symbol of and this plus here is a symbol of or. So when you are having all of this, you have the sum of all these digits. So the sum of all these digits plus sum of all these digits like this. So basically, you're having not A and not B and C, not A and B and not C. As you can see, it's cyclic, and you have not B and not C and you have A and not B and not C, and then you finally have A and B and C. By this, you have the nth. When you have the nth turn, these three digits one after the other, that will form the sum. Okay. Okay, Divya says the textbook is not clear. Is that right? Okay. So Divya, is it clear now? Divya, is this clear now? Divya, is this clear now? Oh, actually, Actually, with a phone I'm doing this, and my hand also. So when I'm trying to talk to you, show you something, my hand is, it's just going up and down, and the focus is having to adjust. So I'm really sorry about that. Uh, you know, uh, I'll be posting this video also. This time around, I have put it on not disturb mode. So as opposed to the previous two, three videos which have been ruined by calls and pop-ups, I don't think this will be so. But again, I'll make a video and do it. So anyway, so this, so as you can see that the sum, the nth sum, you you take in turns A, B, and C as 0, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 1. Like this you keep on taking. And then the carry is obviously given by the same sort of a equation. That is the carry of these. This will construct the the get the this is rather used for the get realization. So this is what it is, the truth table. And this is a very simple truth table, you can imagine. I'm just hovering over this for a minute. As you can see, when you are adding three bits, the sum and the carry, you can match 0, 0, 0 like that. Yes. So now let us look at the next page. Let's just have a look at the adder. Very simple. We use three gates to implement this. So the AND gate and the OR gate and the NOT gate. And we have a, so A, B and C. These three signals are there. Three inputs are there. And obviously we have to have A and A bar both. So we use an inverter circuit, that is a NOT gate. So A with an inverter, B with an inverter, C with an inverter. The branching, obviously we have C signal here, not C signal here, B signal here, not B signal here, A signal here, not B signal here. So that means to say that if you send 1 here, this will be 0, this will be 1. If it's 0 here, this will be 0, this will be 1, like that. Now from there we will have to construct the full adder circuit. So when we do that, we'll just simply use 7 these AND gates. These three will come in here, and we'll be connecting them. As you can see, all these are three input AND gates, and the labels are already here. According to the truth table, you will see the labels. We don't go for 0, 0, 0. Apart from that, we go for everything else. 0, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 1. 0, sorry, 1, is that 0, 1, 1, 1, 0, 1, 1, 1, 1. 1, 1, 0. Beg your pardon, 1, 1, 0. Now, as you know that we have to have an OR operation in between to combine these ANDs. So that is achieved by taking the sorry. That is achieved by taking this OR gates. Okay, that is achieved by taking these OR gates. The results of these is combined with this OR to get you the sum, and the carry. Similarly, the result of these four will give you the carry. This is according to the equation that we've just seen. See this equation. So the first OR gets A naught B naught C, A naught B C naught, A naught A B naught C naught, A B C, and then the next one, the carry, that is the next, this is for the next OR gate. We have A naught B C, A B naught C, A B C naught, A B C. So this is how it is. See, A B C, A B C naught, A B naught C, A naught B C, like that. And similarly here also, A naught B naught C, A naught B C naught, A B naught C naught, A B C. So they're going in. This is the first two. So this is OR gates. First one is for the sum, and the next one is for the carry. That's the gate realization. Now it looks like this. Block diagram wise, if we did three inputs, so out comes a sum, out comes a carry.